Hi everyone, welcome back. This is Raju from Smart AI Technologies. In this video, I'm going to show you crop price prediction using machine learning project. So in this session, we'll be having multiple topics to discuss and to demonstrate our web application which we built using machine learning in the backend. We built multiple models. We imported datasets pre-processed, cleaned. Yeah, we done EDA. Then we built multiple models. Then we implemented this web application, whichever you are seeing now. So which is our front end and back end, where you can get all these things. If you upload the data set, you can get basic information, you can pre-process, you can get EDA1 and EDA2 with a graphical analysis. You can build model by clicking on the model's data. Then you can test the application over the inputs. You can give the details. Based on these details, you could able to get the crop price. Now without delay, we'll start to discuss about the topic. First, we'll try to discuss about the introduction of our topic. Actually, what is the crop price changes and how it is gonna happen, and what impact it is bringing. The crop price changes, what impact it is bringing on the farmers. So all those things we'll discuss one by one. After that, I will be discussing with you the research paper in detail, where we'll be discussing what is there in this present research paper and what we need to do better than this research paper, so that we are going to get the better result. Already we are getting better result because this paper is getting around 85%. So our models are giving more than 99, nearly 99% of accuracy. You can see here any model you take. For example, random forest, you see training accuracy, validation accuracy, and all those things are very good. Okay, so we are getting far better results than the present existing paper that we are referring. So what making our work that much better, and how we are getting that much good accuracies, that we need to discuss. It means we need to discuss this paper, existing paper, and our proposed system. Then I will be demonstrating you in detail about this web application, how we built it, and what are the features are there, and what results they are giving, and what does that results mean, what insights we are going to get from that results, and finally we will test it on a sample data. Okay, what will be price predicted. All these things we'll do one by one. So first of all, we need to know what is this price change. Price change in the agriculture field is that due to some reasons, the fluctuation happens in the prices. It's mainly when it comes to agriculture, it will be grains, fruits, vegetables, and other commodities. Now, whom it will impact? Farmer income, food affordability, and overall economy. So it is most impactful because it will impact on the overall economy of our country. Now, how do agriculture crop price changes happen? What are the main reasons? So due to which the sudden change in the crop price will happen? First one is supply side factors. Under supply side factors, there are four reasons that we need to discuss. One is weather condition. If there is any drought, if there is any flood, if there is any unseasonal rains, or some other extreme conditions will happen. In that case, it will lead to the sudden change in the prices. And if there is any good weather condition, the crop will be grown better and everyone will be growing crop better. In that case also, it mainly depends on the supply and demand. For example, if there is any flood or like that, the demand will be more, the supply will be less, the price will be getting high. And the same thing happens for pest and disease outbreak. This will lead to again the price change rapidly. For example, let us take wheat. Wheat got some XYZ disease and it is getting spoiled. Now there will be high demand, but supply will be reducing to very low level. In that case, the price will be increased to a lot and lot. The same will happen with input costs, maybe fertilizer price increased, pesticide price increased, or fuel price increased also, that will impact on the crop price. And technological advancement, you mean if there is a one crop you need to cultivate using some technology, if that cost a lot, then that cost will be on the price of the crop. So automatically this will be increasing. Otherwise some technologies will be helpful. they will, when people will use that technology, the price of the crop will be reduced, because less human intervention will be happening there. So it will be of a better profit for them farmers. So sometimes it will lower the prices. And demand side factors. Now the demand over the crop required, the demand over the food required, what are the impacts, what are the parameters that are impacting here? One is population growth. It's directly proportional, because if population increases, demand will increase, supply will be less, then the price will increase. The same for economic growth. Okay, so with the economic growth, whether it is a positive growth or negative growth, based on that also the price hike and drop will happen. And dietary changes. Now you see present organic or non-GMO products are increasing, so these prices now will be getting increased. Particular demands, particular dietary changes, people who want particular type of food to be eaten, if there is a lot of demand over that, okay, but there is a less supply, automatically there is an increase in the prices. Export and import policies. So this export and import policies will impact a lot on global market mainly, you can see here, and it will directly influence on the prices within the country and outside the country directly, because a lot of things that being grown in a country will be moved to some other countries, that is exported a lot. So if there is any changes in their policies, it will impact on the entire economy. So that directly come to our price cost. And third one is market dynamics. And this here speculations, mainly speculations, what will happen, which crop will be in loss, which will be profit, like that. If there is some speculation coming up, now the price will be now getting varied based on the speculations. Some people say if wheat is getting going to get into loss, then people will try to sell everything now itself. In that case, something will happen. So these scenarios will impact again on the crop prices. Supply chain disruptions. Then comes government policies and subsidies. So what type of policies government are making, and what type of subsidies they are providing to farmers. And regulation and standard over the food. What are the causes of crop price changes? Again, I mentioned all the things above, same things, just in a different way. Natural disasters, pest impact, economic shocks, that we discussed now, same thing will happen. Global market fluctuation, maybe due to policies, or maybe due to war, or like that. Technological innovations, again we discussed, due to different technologies that are coming up, maybe it will be profitable or loss. So if some technologies that are helpful with a low cost and they can produce a high product, the cost will be reduced. But if there is a technology which is hard to get or high cost, in that case the cost of the price will be increasing. Impact on the market. First of all, it will be inflation and food prices. So what will happen? Always inflation will happen. When inflation will happen, the prices of everything will be getting increased. It's very direct. And market volatility. Fluctuating crop prices can create uncertainty in the market, making it difficult for the business to plan and for government to manage the food security. Volatility can lead to speculative behavior in the commodity markets. When this speculation will enter, there is always unstable market, because speculation says something gonna increase, something gonna fall. So based on that, people will try to take a decision before that. So that will make market most unstable. And mainly all these things will come back to farmer itself. They will impact much on farmers than the consumers. So income volatility, farmers, they will not get better income. Okay, investment in agriculture, if they won't get better now, they won't invest a lot in the next time. Okay, debt and financial stress. For example, due to a lot of flood and all these things in the present scenario, farmers are in loss and there will be debt. Now it will make them very hard to work on it. Shift in a crop prediction, that is there, because now you see in Karnataka and some part of regions, mainly there were previously cotton and mainly cotton and jowar are being grown, but now they are shifting towards the rice, so it also impact a lot. And even chilies as okay. So like that, if people are shifting from one to other, there is a change. Okay, there is a change in prices even. And when it comes to farmers, they are mostly from rurals, so the direct impact goes to rural communities. Now what to do to resolve this stuff? So here we are trying to take up our machine learning technology in a multiple way. So how we can help? Because with our machine learning technology, what if we can predict what will be the prices in the market, in the particular area, in the particular market, in the given scenario? In that case, it will be very easy for farmer to understand and take decisions. It will not be just a speculation, it will be a calculated number which will be more accurate than the just speculations or imaginations. What will happen, how like what will be the prices at that time or this time and all those things. Instead of that, our machine learning models will be giving you a proper number. This was the price will be, in this range the price will be, like that. So that will resolve the most important problem here. Now in our project, what are the methodology that we are following? First, we are collecting the data set, then we are going to do the data pre-processing, then we are going to do the EDA, then we are going to add multiple models. We are going to train them, we are going to test them, we are going to evaluate them, and then we're going to build front end and back end with HTML, CSS and Flask in the back end that previously you saw that web application. So this we are going to build, and we can able to give you the documentation support also. We Smart AI Technologies provide final year project supports or some startup with their requirement. We even help them to build the technologies and we provide them. So if you are a final year student, MTech, BTech or PhD, so you can approach us and you can get these projects and you can get the entire documentation support, entire code, and classes will be held, the discussion will be done and the mentorship will be done. It means once you get this whole project, we will be mentoring you throughout the process. And what are the hardware and softwares are required? Here the hardware part, you can have any type of OS, but you need to have minimum 4 GB RAM, 8 GB, 16 GB is much useful. Then storage minimum 500 TB, minimum 250 I'm sorry 500 GB is needed or 1 TB is needed. Better if you have any GPU. And when it comes to server, here we are trying to deploy it locally, so we are using Flask. So local server is enough. Or if you want to deploy it in AWS or Google Cloud, you can have that cloud keys. Now software requirement. We are programming our code with Python. With this Python will take around 90% of it. And then HTML and CSS will take around 10% of it. So these are all the libraries or technologies that we are using: scikit-learn, TensorFlow, Keras, PyTorch, Pandas, NumPy, Matplotlib and Plotly. Yeah, so now for the server side, we are using Flask. Okay, now we're going to discuss about the paper. What is there in the paper and what they are discussing about the project and what they implemented and how much accuracy they are getting. So we directly jump to their proposed system. Okay, so they are focusing on the pricing of the rice, wheat, milk and fruit. It means they are going with the limited categories now, and with the mangoes also. They are using NAFA data source and it is being collected from 5 years. So they are using mainly naive bias as they are mentioning it, and they are getting around 85% of accuracy, which is they are saying 85% they are getting at max, because they are even trying to build some other models also in the down. They built random forest, they built decision tree, they built SVM, but they say in this paper they say they are getting better for naive bias 85% accurately. They are using multiple models as I mentioned you, random forest, okay, and decision tree and SVM. Now they are plotting this one. Even they are following the same step, because they need to follow data science life cycle stuff: dataset collection, pre-processing, okay, and they need to use the model whatever they are using, feature extraction, apply algorithm, classify and accurate. That's all. And they are doing random selection of the features. But in our case we are applying few technologies which are better than this. I will be discussing you under our proposed methodology. This is existing system of this paper, so we are doing better than this paper. What we are doing better than this paper we will discuss one by one now, okay, after discussing this paper. And the process flow chart goes like this: dataset and NLP, pre-processed data will be given to algorithms, neural network, proposed dataset. And you can see here algorithm and accuracies. So they are using mainly 3 algorithms, and they are not mentioning accuracy values directly here, but they already mentioned it, that they are getting around 85% of accuracies. So they are getting confusion matrix and everything. Now we will see what we are doing new here, and what is our proposed methodology, and how we are detecting the gap, the research gap, what you say. So what is the research gap here, and how we are fulfilling that research gap, and what are the techniques that we are mentioning so to overcome this problem. Now the first part is that I'll be showing even the part of course later. So the first part that we are doing is we are handling the null values. The null values are nothing but there is any missing values in our data set. That missing values are not being handled here. Maybe there were no missing values in their data set, so that's why they didn't handle. But we need to check and we need to mention if there is no missing value, we need to leave it. Otherwise, if there is any missing values, we need to handle it accurately, because there are so many techniques to handle. So we are concentrating on that. In our case also there were no missing values, so we skip that handling the missing value. Here you see there is no missing value, so we are leaving that part. So otherwise, if there is any missing value, we needed to handle it. And then comes the mapping technique. Now there will be some columns which will be having the values and names. For example, this is our data set. This is our data set, which is date of recording, state, city, crop type, season, temperature, rainfall, supply, volume, demand volume, transport cost, fertilizer usage, pest infestation, and so many things. Here there are some columns which are not numbers, they are variables. So we need to handle this. You can't build any machine learning model with the object type columns. So that's why how to handle these things. To handle this, you have multiple ways. You have one-hot encoding or mapping technique. So in our case, we are going with the mapping technique. So we're gonna map As you can see, we are going to apply the mapping technique. Then as it is, we are first building our model. So here the next part is feature normalization of the data. What is mean by normalization and what is its importance? So this paper doesn't speak anything about that. So normalization nothing but if there is a column, in our case, if this is a column, temperature is a column. Now it is having a value 37, 21, 36, 19 like this. Now what if these values calculating with a large number of values will take a lot of time. So that's why what we will do for the entire temperature column, what if we divide everything divided by the maximum value, 37.1 divided by the maximum value here, maybe 50, 21 divided by 50, 36 divided by 50. So when you apply this normalization over this column, it will be having a values from 0 to 1, 0.02, 0.12. You can see that changes happened here. You can see the changes. Temperature now become 0.884, 0.24, 0.852 because we are dividing all of them divided by the maximum value in that column. So that's what we say min-max scaling we are doing. Now, what is the impact? What is the impact that is causing on the model? So normally to showcase that, we normally build a normal model. Okay, then we build a model on the normalized data to showcase there will be a positive impact on the result. And it doesn't mean like every time it should be having a positive impact, but always there is a chance, more than 50 to 60% chance, that when you work with the normalized data, the speed of the calculation will improve. For example, if you are having a bulk data set, sometimes if you go as it is, it will take a lot of time, and sometimes the system that you are using may not be capable of handling that. So when you normalize, it will easily handle the data. One thing, the normalization of the columns, and then we are getting all these things. Now feature selection. Under feature selection, again if I go to this paper, under feature selection, they are not adding anything specially for the feature selection. It means they are not using any rules or anything for a feature selection. But with us, we are going with the two techniques. One is wrapper technique, another one is lasso. Now when we apply that, is there any change in the accuracies? We need to understand, because the accuracy is the main thing that we need to have train R2. So this is accuracy. So for that, what I will do, this is before applying the feature selection. What is mean by feature selection, I will tell you. For example, you go to a showroom, car showroom, and you want to buy a car. Now same brand, and you are having 10 cars. Now you look over all those cars, and now what you will ask for the person or manager, you will ask what is the capacity, what is the engine type, what average it will give, what is the maximum speed. Okay, and almost if you go further, and you can ask what type of metal is being used. If you want to know in-depth information like that, you will ask. I don't think you will ask about the color. It means you are asking all those things for the purpose of price. If you are asking for the price, color doesn't matter a lot. Okay, for the price, color doesn't impact much on the price car. So now at that condition, what you will do, you will try to leave the color. You will try to ask all the main importance. Okay, how much HP and all those things. You will ask about the engine and all those things. You will ask one by one. Now at that case, all other features are becoming most important features, whereas color of the car is becoming the secondary. It means even though you leave color of a car, the price of car doesn't change. The price of car depends on other parameters: engine type, the capacity, the body, and the length, the number of seats, and so on, so on. So here you need to remove the unwanted feature which is not impacting on our result. So that is the reason we say feature selection. For that purpose, first we are going the wrapper technique. So when you try to do like this, when you try to take only the most important features and leaving the not important features, there is again the faster training will happen, the model will learn easily, the model will learn better, and you will be having a much chance to get a better accuracy, and the loss will be reduced. Root mean square error loss will be reduced. So you can see here this result for XGBoost before applying the wrapper techniques. I used all the features as an input, whereas when you come here, I have selected few columns based on the wrapper technique. When I use this few columns wrapper technique, and when I go here, even my loss is increasing. So this wrapper technique is not impacting on our result a lot. So then what I will do, then I'm going to apply another feature selection technique called Lasso. So these two are different feature selection. So when I apply Lasso and when I select the most important feature based on the Lasso, then I gonna build a model. You see the changes, 7.05 it decreased, and the accuracy now 99, 99, 99 for all of them. Main is the test auto score, test accuracy, it is 99 here. So it means feature selection if you do with the Lasso, you are increasing the accuracy of the model far better, and you are reducing the loss. And then like this we are going to build multiple models. First one is the XGBoost. Then this one is the random forest, which is having very less loss, so which is having 100% training accuracy, far better than the XGBoost. Then comes the linear regression. Here our model is not doing good. It means linear regression is not a suitable model for this problem statement. And then comes the SVR. SVR also is not the best model for our solution, because random forest is fitting lot more better, and it is giving only 86% this one SVR, but our random forest was giving more than 99%. And then comes the AdaBoost regression, which is also not giving good accuracies. Here we used multiple models. AdaBoost we used, random forest we used, SVR we used, linear regression we used, and XGBoost. So among all of them, the best model that we are getting is the for random forest, which is having almost 100% training accuracy and testing accuracy 99, as well as root mean square error is 3.91, which is very less than all these models. So our best fit model is random forest model. So then we'll take this best fit model, then we gonna interact with my front end and back end. For front end we used HTML CSS, for back end we used Flask. So we gonna integrate both of them. So we gonna integrate the best model there for the front and back end like this. So this is our home page. So this is our home page of our website that we built. So when you click on here, crop price prediction using machine learning, it will take you to this page where you need to upload the data set. And then if you want to know the basic information of the data set, just click on the basic info. So it will give you what are the columns are there, top head columns, top head rows are coming here 5 to 6, and then comes the shape, how many rows and how many columns. Total 48,000 rows are there and 13 columns are there. Then describe, what does this description will give to us. For example, let us take temperature. So for temperature, mean is 27 degrees Celsius. It means whatever the collection we made, the mean average temperature was 27.5, and standard deviation which says maybe there are some places which are 7 degree more or 7 degree less than this. The variation from the mean, that is standard deviation. Minimum 15 degree. There are some locations where 15 degrees Celsius temperature is there, and there are 25% of locations in our data set which are having 21 degrees Celsius temperature, and there are 50% of data where 27 temperature is there. 75% of data where 33, around 33, 34, 35, like this temperature records are there with us. There are total 40,000 data available. Sorry, maximum is 40 degrees Celsius. Total 48,000 data are available. So like this, you need to check for rainfall, supply volume, demand volume. For all of them, you are going to get the information that you can get a description or the analysis over the data set. Now here we are getting the information. So this will give us the information like what is that column, what type of data it is having. So state was having object, city was having object nothing but they are having string data. Rainfall is number, so float. Temperature is number, so float. All these informations are being given here. So now we are gonna apply pre-processing over the data set. In our data set we don't have any nulls, so that's why we don't needed to handle the null values. If there are any null values, we needed to handle it. So there are no empty values in our data set. Then I am going to check again the data from display, and this EDA may take some time. In this EDA we are trying to plot some graphs. Yeah, you can see distribution curves we are getting. So for example, temperature, if you take, it says that there is a normal distribution. It means below 20 there is no location, there are no more locations, and above 40 there are no locations with that much temperature. But 20, 30, 40, there are almost equal number of locations which are having 20-30 degrees Celsius, 30 to 40. You can see the changes here. Price, as well, price, what it means, more crops, their prices were around 0 to 200. There are less from 200 to 400, and like this it will give us the distribution of every parameter. You can see here how the data is being distributed, in which range there are values and which range there is no value. Same thing for categorical columns. Okay, here now with us the data is distributed properly. So for Karnataka we have more data. We have around 17,000 and more for Karnataka. For other states we have around more than 5,000, around 6,000 for each state. So for Karnataka it is having more states, so that is being given here. Other than that, for every state the data collections are almost equal number of data are being collected. Then comes the most important thing, that is heat map. What does this heat map will give us? We call this as a correlation matrix. So here, for example, how to analyze this I will tell you. The last one is price from x-axis, and you can take volume or you can take temperature. So for example, I will go with I will go with the demand values. Opposite. Okay. So now you see 1 and 59. It means the price where they meets the demand value. It means if there is any high demand, the price will increase. There is a 59% relation. If there is a demand increasing over any crop, there is a price increase. It is directly proportional. This is that much impactful parameter. You can see another one is given 0.44 minus 0.44 minus nothing but opposite direction. Okay, supply chain. If supply is decreasing, price is increasing. That is 45% relation. So supply and price are reversely correlated. So that's why you are getting minus. So no probability value will be minus. If there is any minus, it means it is happening in the opposite direction. Like this you can check for any combination of any parameters how they are impactful on each other. Mainly our target should be the last column, because our output how it is depending on other inputs. Now when you see rainfall impact is also there. 5% impact is there on the price, and the temperature 0.1% 1-2% impact is there on the price. But why it is not giving a lot? Because we are having many areas data sets, not single area data set. It means with that area also, if there is a high temperature, they will be growing the related crop there. So here the data is not impacting a much. For example, if you take only one location and if you take temperature high and temperature low conditions, then you will understand far better how temperature is impacting on the price clearly. and you can able to see EDA data too, which is also having some graphs like violin plots and some other graphs. Our model building will take a little bit more time because of the use data that we are having, because we are building here, we are trying to display 3 models, but in the backend, as I shown you the multiple models, how I built it, all those things. And in our YouTube in our YouTube channel, we have so many videos with so many other topics where you can just visit and check those topics if you want to work on that. Maybe on agriculture, maybe on handwritten text, or some other things. We are around 114 to 115 videos already existing, so you can check and we will be getting some other ideas to work on the project, and you will be learning a lot. Okay, there are so many videos which are for free where you can watch them for free. Maybe there is a complete data analysis using Excel course, you can watch that. I can show you our YouTube. So this is our channel, Smart AI Technologies. You can just visit. Okay, anyway you are watching this video, you can just visit and check these things. You can see here Parkinson disease detection. There are around 114 videos already available, and including this 114 videos are there. So you can see here. Okay, different domain projects are there. We are not limited to only one type of domain, and some blockchain projects are also available, you can check them. And this is a complete Excel course is available with us. So here you can see a few graphs are being displayed. One is violin plot that you can see, which is the distribution again, where the prices, the more prices is distributed, there is a wideness. The white dots is the median. Around that region only there are so many prices are moving on. So there are so many products which are having less than 400 and in middle 200 to 400. There are few. Most of them are concentrated between 0 to 150. We call these graphs as relational plots. What is the relation between the price and the supply value? So when the supply value increases, the price is decreasing. When the price should increase, the supply value should decrease. So there is an opposite relation. This we already saw with help of correlation heat map. The same thing that is being displayed here. So then comes the supply demand volume and supply volume. We are plotting two graphs. Okay, so here demand volume and the price. So when the demand increases, there is always increase in the price. So that is being shown here. And with rainfall, the price increase, there is a little bit variation. So it is not a direct impact. So that impact that we can't see clearly here, because there is not much impact directly on the price due to rainfall or temperature. So mainly here we are trying to show it in the form of rainfall. So when you click on the models, you can able to see the model details. It will take a little bit time. We will wait. In the same time, you can just click on the like button and click on the subscribe button, where we will be coming up with some other new videos and ideas that you will be getting in future, and some good projects. Mainly we are concentrating on working with voice files. So there are some good ideas or project titles that are coming up. So if you click on the bell button, you will be getting notified with them. You can watch those videos whenever we deploy to our YouTube channel. You can see here the details about the models. So here we are only trying to display only about 3 models, but as you can see in the back end we have implemented so many models. You can display all these things there. You can take SVR, you can take XGBoost, AdaBoost regression, and you can paste all of these there. But why only added 3 model details? It was taking lot of time for me. So even I paused the video, so it was executing for a lot of time. That is the reason. Okay, even though we done normalization and feature selection, then only it is taking this much of time. If you want to do that, it will take double or thrice time for the model building of these things one another. So here we have random forest, which was giving lot good model, a lot good accuracy, and our loss was very less in this case. And support SVR we are printing, and their accuracies, their losses MSC, mean square error losses, we are printing out. But you can print all these things, all these models informations, you can print it on that particular page. So once we could able to build a model for our data set, we go on do the testing. For that you can select any Maharashtra, Mumbai, and which crop is that, and what is the season, and what is the temperature around 31, and what is the rainfall, 1 2 3 2 4, some random values I am putting. If you want to put the exact values, you can take it from here. What was the rainfall and all those things you can take there. And I put around 230. Supply volume you can take, you can refer. So if you are not good into it, you can refer. So let me take supply volume is 4000 supply volume. Demand is very less. So how much impact it will bring on our results, you will understand now. Transportation cost maybe 4 rupees. Fertilizer usage per kg maybe 1-2 kgs. Pest infestation maybe 20%. It means we can say 0.3. Market competition, there is a high competition, so we can say 0.9. So this is giving us 94 rupees per kg. So now what will happen? We change that parameter. We say supply volume was high and demand was very less. What happens when I exchange this? Supply is very less and the demand is very high. The price you see 304. The price for the wheat increased more than twice, even more than thrice. So this is the reason. What is the demand and what is the supply? With that you can change season types. It will go on changing, but these are not much impactful parameters. That's why I'm showcasing you what is impactful and what is not impactful. Let us go to pro monsoon. What impact it will bring on the prices? Not much. There is in rupees mainly. And transportation cost. What if transportation cost increases because of the increase in the price of the petroleum products? Let us say 10 rupees or 20 rupees. It will also impact a little bit, not much. So again, transportation cost ranges we will see first. Okay, transportation is very high number. we are giving very less. So let us take 500. So now you see the things are changing. And fertilizer usage will refer here. Normal fertilizer usage is 200 like this. Okay. So let me give 400. It is increasing. It will go on increasing. It was initially 90, so it is increasing. And after that, forced infestation phase is 0.9. Okay. It will go on increasing. If you decrease it, it will decrease the value of that crop. You can even change the crop and see. what will be the same impact on the price, how the values will change. And you can take here rainfall goes 102. As we done our analysis, rainfall is not impacting on the prices a lot, 177 to 162. So this is our final implementation of that project on the sample values. So our project contains so many things, starting from dataset importing to the pre-processing, analysis, model building, EDA1, EDA2, all of them. We are integrated it as a web application. Before this, we need to do all this analysis in the backend. We need to try multiple models, multiple techniques, which are far better than the existing paper, so that if you want to write your own paper, it should be acceptable. So your proposed methodology should be better than the existing system. We are already getting good accuracies. So our proposed system is far better than the existing system of our reference paper, this paper. This was all about today, and in the next video we will be coming up with some good project. So if you are still here now with us, you can just click on the like button and subscribe button. And thank you very much. We'll see you in the next video.